I would like to talk with you about factoring expressions of the form a cubed plus b cubed and a cubed minus b cubed. We call these, because it's a sum of two cubes, we call them the sum of cubes. And here we call this the difference of cubes. Now, before I actually get into the meat of this lesson, I'd like to remind you guys of some common cubes. So here I'm just going to write 1, 2, 3, 4, and 5, and here I'm going to write what the cubes of each of those numbers are. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. It would be good to be able to recognize those numbers and spot them as they come up. Let's say that I have a cubed plus b cubed, the sum of two cubes. Well, this is going to break down into a binomial times a trinomial. Now, in order to figure out the signs that we're going to use, it's helpful for you guys to know the acronym SOAP. I'm going to write it over here, SOAP, S-O-A-P. S stands for the same. O stands for opposite. A stands for always. And P stands for positive. Same, opposite, always, positive, SOAP. So before I actually fill in anything else, let me just get the operations down. I know that these two are going to be the same, so that makes this a plus. And then these two are going to be, these two are the same, these two are opposite, that makes it a minus, and this right here is going to be always positive, which makes that a plus. The way that I fill in the rest of it is, here I have a plus b, and then here I have descending powers of a and ascending powers of b. So a squared minus ab plus b squared, descending powers of a and ascending powers of b. Now, it turns out that a cubed minus b cubed follows the same procedure of SOAP. Well, it breaks down into a binomial times a trinomial, and then the signs here are going to be the same. The signs here are going to be opposite, and then this is going to be always positive. Now it's just a matter for me to fill in the letters. So this is going to be a minus b, and then again I have descending powers of a and ascending powers of b. So I have a squared plus ab plus b squared, descending powers of a and ascending powers of b. Well, let me go ahead and actually fill this in with some concrete numbers. Let's suppose that I had, for instance, x cubed plus 125. Well, from what we did at the beginning, I hope that you recognize that 125 is just 5 cubed, a perfect cube. So the way that I'm going to write this is going to be a binomial times a trinomial. And then my signs are going to be the same, and then opposite, and then always positive. Well, what I'm going to have here is x plus 5, and then what I have in the trinomial is descending powers of x and ascending powers of 5. So it's going to be x squared minus 5x plus 25, because 25 is just 5 squared. I have descending powers of descending powers of x and ascending powers of 5. Let me go ahead and clear off some board space and see if we could work out a few more of these problems. Let's suppose that I had c cubed minus 64. Well, I recognize that 64 is just 4 cubed. Now, I also know that this is going to break down into a binomial times a trinomial. And I know that the signs are going to be the same here. These two are opposite, and this is always positive. Well, I know how this is going to be. It's c minus 4 for the binomial. And then I need to have descending powers of c and ascending powers of 4. So it's going to be c squared plus 4c plus 16, because 16 is just 4 squared, descending powers of c and ascending powers of 4. Well, how about this one? What if I happen to have 8a cubed plus 1? 8a cubed plus 1. Well, this actually is a sum of two cubes, because the first one is actually 2a cubed. And also 1 is just 1 cubed. So this one's a little tricky to do, but it's going to follow the same pattern. It's going to be a binomial times a trinomial. And I know that the signs here and here have to be the same. These signs are going to be opposite, and this is going to be always positive. Now, for a problem as complex as this, I'm actually going to take it in 2 steps. And so right here is not going to be my final answer. I'm going to go ahead and have this be my second to last step. So what I have is 2a plus 1, the 2a coming from here, the 1 coming from here. And then I have descending powers of 2a and ascending powers of 1. So this is going to be 2a squared, notice how it's in parentheses, minus 2a times 1 plus 1 squared. My last step is just to do some simplification. This is going to equal 2a plus 1 times 4a squared minus 2a plus 1. This is going to be my final answer. Let me go ahead and do one final problem and clear off some board space so that I could have plenty of room to write. I want to do this because I think that most students, or many students at least, would do this problem incorrectly. And I want you to be aware of it. I have 8x cubed minus 64. Well, as it turns out, this is already a difference of 2 cubes. But you don't want to immediately go to your answer. Your first step when factoring is always ask, can I factor out a greatest common factor? Well, in this case, they have an 8 in common. So the first thing that I want to do is actually factor out an 8, and then I'm left with x cubed minus 8. This also is a difference of 2 cubes. Well, I'm just going to keep the 8 along for the ride, and then this breaks down into a binomial times a trinomial. And here, 8 is nothing more than just 2 cubed. So this is, well, the signs are minus, plus, and then plus. Same, opposite, always positive. So this is going to be x minus 2, and then descending powers of x and ascending powers of 2. So x squared plus 2x plus 4, because 4 is just 2 squared. Go ahead and box that. That looks like my final answer. This is Cliff Nelson from Redwood Tutoring. Thanks for joining me.